We are delighted to have Weilun Son with us. Will is in the Texas Academy of Mathematics and Science program, and I believe has been doing research most of his 2 years with us. We also have Dr. Bill Acree, professor extraordinaire in the Department of Chemistry here at UNT. So Will, I'm going to turn it over to you. I do want to read the title of the presentation, Will, although this may have changed, but it's called Doc Talk, Combining Dependency-Based Text Graphs and Deep Learning into a Practical Dialogue Engine. So Will, take it away.
All right, thank you very much for the introduction. That is indeed my title, and I will go ahead and share my screen. So I just prepared a quick PowerPoint presentation. Can you guys see it? All right, sounds good. So yeah, Doc Talk, like Dr. Gruber said, this is a dialogue engine, an interactive dialogue agent, which allows the user to upload a document, which the algorithm behind the dialogue engine will then either summarize it or answer questions based on what the user asks. So before I go into that, I'd just like to make a quick remark. So this was done in collaboration with Dr. Paul Terrell of the UNT Computer Science Department, fellow TAMS student Yifan Guo, Ali Khan, who's a senior at UNT, and also Tam Don, who is a postdoc student here at UNT as well. This paper was also submitted to the 14th International Conference on Flexible Query Answering Systems, the link of which can be found there. And also for this paper, I will be mostly just going over the overall system architecture and the results at the end, rather than going into detail about how exactly the algorithm was developed. So if you'd like to take a look at the entire paper, a link has also been provided. It's the final paper, WS1. So moving on, text summarization and question answering. So this is a quintessential part of natural language processing, and which is essentially what this paper or my research is about. And text summarization can essentially be split into two separate fields, abstractive and extractive. The difference between the two is that abstractive, the summaries provided are created using your own words, rather than the words taken straight from the article. Whereas extractive, it just pulls the sentences straight from the article and then it provides those as the summary. And there's pros and cons to both. So extractive text summarization is arguably more accurate since the wording and the phrasing is exactly as it is provided in the document. So there is like no room for misinterpretation. With abstractive text summarization, one of its benefits is that it can answer questions and do things that aren't explicitly stated in the article itself. So it gives us more room to ask more creative questions, I suppose. And there's also two separate ways of dealing with text summarization and question answering. The two ways are using text graphs and neural networks. Text graphs are a more traditional method, I suppose, whereas neural networks are like a hot kind of new technology these days. One of the benefits of text graphs is that it allows for the processing of really long documents. And it's very precise since each of the words in the document, or however you want to structure the graph, is connected to each other, and you can visualize which nodes are part of which words are connected to which, and then find a summary and answer to your question using the graph. Whereas neural networks, it's using a large data set to train itself, and then it will learn how to basically process this document on its own. And as there's benefits and disadvantages to both, we decided for our interactive web interface to use a system which combines both text graphs and neural networks to get sort of the best of both worlds. So here is the overall system architecture of our web interface. So you have the user, and he or she interacts with the web interface, which also is connected to a document collection. So first, the web interface really feeds the document to this Python-based document processor, which creates a dependency graph, which I'll show on the next slide. This graph also is fed to the question answering dialogue engine, which uses BERT, which is the neural network program or neural network package. And it uses that to create two types of answers for the questions that are being asked. And here's an example of one of the dependency graphs. And a dependency graph is basically you take the words from the document and you basically say which of these words depends on the other words. And there's a lot of different types of dependencies. One of the ones you can see clearly are the has instance ones. And there's also ones that connects various synonyms, words that are like dependent on each other, like color and red. So those words would be connected. And basically, overall, you have this entire text graph, which depending on the algorithm that's being used, it can separate the nodes into specific words. Some researchers in the field that are working on text-based natural language processing, they like to have entire phrases in these nodes. It's really up to the researchers to decide what type of graph they want to use and how they want to customize it. And really that is the basis for like the uniqueness of this sort of research. And the way to like answer a question using this text graph is you want to focus on the distance between nodes. So let's say we ask a question about the Constitution and the question contains the word president, which is in the center or like the bottom left of the text node or text graph. As you can see, there's a lot of connections to that node. So therefore, the immediate connections will be first parsed by the algorithm to determine if they are applicable answers to the question, and then it will construct an answer from that. So moving on, I want to talk about the web interface which we constructed. The web interface is essentially just a shell which houses the algorithm that we built to create these summaries and answers to the questions. The web interface is built using Streamlit, which is a Python package that allows us to create a good looking but also lightweight interface without using a lot of HTML, JavaScript, and Flask, which is traditionally needed to create a web interface from a Python program. The benefits of Streamlit is that it's sort of like a website creator like Weebly, except it's all based in code and there's still a lot of customization available without needing to go through the nitty-gritty details of web development every time. Another benefit of our web interface is file uploading, which I mentioned earlier, but basically this accepts text documents at the time. And in the future, we plan to modify it to allow PDFs. And basically the file upload is just what the user uses to choose what file they want to summarize or have questions answered based on. The file upload is limited to 200 megabytes of data, but that can also be changed on our end. And finally, we have language detection, which is one of the main features of our web interface. And basically what language detection means is that when you upload a document, it automatically detects which language that the document is in, and it will provide the summary and question answering in that specific language. Moving on, I can show a live demonstration here. So this is the screen that is brought up when you go to the main page. And basically, we can select the document on the left-hand side. One of the ones we use for text testing is this English.txt document. And it'll start to analyze it. And this document is about Roger Penrose and his contributions to science and how he got his Nobel Prize. So this will take a short amount of time to analyze, and then it will display both the summary and the keywords of the article. So yeah, as you can see here, it provides a short summary, also the keywords at the bottom. And the question answering part you can access by just switching this to ask a question. It will quickly reanalyze the document, which will actually be parsed out during future versions of this interface. And we can ask a question, for example, when did Roger Penrose win the Nobel Prize, ? And yeah, so basically the algorithm displays these two sentences, and it says that he won half the prize for his 1965 paper. So in 1965 would be the answer. So as you can see, this also emphasizes the difference between abstractive and extractive text summarization. If this was an abstractive algorithm, it would say Roger Penrose won it in 1965. However, since we're extracting sentences from the document to construct the answer, you get these sort of sentences which aren't directly answering the question, but depending on the document, they can either be like inferences or directly answering it. So for this document, it's not very direct, but you can get the idea. So going back to the presentation, another example of what this document processor can do is process documents in Chinese. And I actually cannot read Chinese. This was done by Yifan Guo, and he uploaded this document. And this is just an example of it detecting that the language is in Chinese and outputting the summary and keywords as such. So moving on, how do we know that the summary and questions being asked are being answered appropriately? How are the summaries? How do we know that they're actually summarizing the article? Well, for one specific article, you can just read it and you can tell if it's a good summary or not. However, we want a large data set, which means that we have to evaluate many summaries of many articles. And since that is very labor intensive, we introduced these 3 data science metrics, which I'm sure most people know about since they're used in chemistry, physics, and all of that, and precision, recall, and F1 score. And in the context of natural language processing or this specific paper, what precision mean is what percentage of our response is actually relevant. So the summary that we give, how much of the summary that we provide is actually summarizing the paper rather than junk, I guess. And recall basically says what percentage of the original paper that we successfully captured in our summary. And finally, the F1 score is this sort of combination of the two. You can set it to be 50-50 as a harmonic mean, or you can set it to be various percentages, but basically it sort of combines precision and recall into one score to allow you to evaluate both sides. And for the state of the art research right now, the F1 score can be usually around 40 to or 0.4 to 0.5. And that is using a purely neural network based system built running for short documents such as the CNN and Daily News data sets, which are basically just articles taken from CNN and sorry, not Daily News, Daily Mail. So yeah, 0.4 to 0.5 is about the state of the art F1 score at the moment. A few applications of our research, it can be used as a teaching aid. So students and teachers can basically submit their questions into whatever document or material is being used at the time, and they can have their questions answered without conferring each other. Scientific research is very useful for that sense. Our combination of neural networks and graph-based analysis allows for the processing of very long technical documents, which neural network systems alone cannot do effectively. So basically, scientific research, technical manuals like your car manual, you can easily find things within those papers and those texts that would otherwise take time to look through. Basically, that was just the entirety of my interactive web interface. It's basically built on PyTalk, which is the algorithm we use to summarize and answer questions about documents. And overall, it's a combination of neural networks and text graphs, which is pretty much our new contribution to this field.
Outstanding, Will. Thank you very much. I'm going to ask Dr. Acree if he has a question or two.
I'll just ask the one. I noticed that in the example you were given about William Penn or whatever, Penn, it came up with the incorrect answer. That was not the year that he won the Nobel Prize, because the Nobel Prize is won many years after one's paper is published. He won the Nobel Prize in 2020.
I see. So I think that that's one of the disadvantages of having this extractive text summarization then. So if you look at this document, which doesn't display on the entire screen because I'm wording it in, I'm running it in Notepad. But in this document, I don't think it states anywhere that he actually won the Nobel Prize in 2020. So therefore, when I answered the question that wasn't explicitly stated in the summary, what it did is it tried to produce the best answer that it could, which is 1965. So I think in a case where we're asking a question to the document that the answer isn't explicitly stated, then one of the things that we should work on in the future is basically telling the user that this answer is not confident. We're not confident enough in this answer to display it at the moment. So I think that would be one of our future, which is something we are working on, trying to improve this system. But as of now, that's my fault for asking a question that was not actually stated in the article.
Well, I was just thinking about using it eventually to replace the instructor of a class.
No, I think that's definitely
the wrong answer.
That's definitely something that like is a long-term goal of research like this, right? To try and create things that help both instructors, students, help them with learning, that things they wouldn't be able to do previously. So I think like as this research continues to develop and this field in general, I think we will start to see things like that where a program can just sort of, or not, maybe not necessarily teach a class on its own, but really supplement the instruction.
Nice. Very nice paper.
Thank you.
Krista, do you have a question for Will?
I do have a question. I'm sorry, I think you answered this in part, but I'd like to hear a little bit more discussion on it, if you will.
Mm-hmm.
I can formulate my own theory, but what would you say is the main benefit to having a program like this available?
The main benefit.
Yeah.
I think for the applications, it's hard to describe a main benefit because you have to really decide which you want to use it for. But I think one of the ones that we were most excited about when we were developing this paper is the potential for academic instruction. So like if there is an article that a student is assigned for homework and they do not understand something about it, or they want a quick summary of it, then they can input said article into the interface, and then they would be able to get a summary or have their question answered without having to contact the teacher if they were at home or something like that. So they would be able to do it all by themselves without like a bunch of extra steps needed. I feel like that is one of the main like uses for this in the future.
Okay, thank you.
Mm-hmm.
Will, I have one question, and it may not be relevant to what you actually did, but I think back to some of the fairly complex sci-fi films from Hollywood, and I know I've heard the term neural network.
Mm-hmm.
Is this the technology that those sci-fi films, I guess, are describing when they talk about some sort of robot or cyborg learning how to speak or acquire language?
Mm-hmm. So I think not exactly. What differentiates that between this is really for the benefit of the user. I think for things like that, that is also in the field of natural language processing. And neural networks are very prevalent, and machine learning in general. But that's just not what we're doing exactly. We're mostly trying to have this understand the article at hand. And since we're mostly using text graphs, it's not learning the entirety of how to speak the English language. Although that is something that can be trained in a different section of NLP, and there definitely is work on that. But yeah, what this is mostly for is benefiting students, whoever wants to have a long technical document summarized.
Okay, all right. Well, Will, thank you very much. I agree with Dr. Acree. Very good paper and very good work. I do want to have a shout out to Krista for being our technical host today. For anyone wondering, Krista works with the TAMS and Honors College, and she works directly with TAMS students a lot. So we want to thank her for doing what I probably would have messed up today. So thank you, Krista. And thank you all for being here. And Will, thank you again.
Thank you all as well for being here.